So actually, that wasn't one I was counting. So we'll have 2 more still. That is true. No?
The diagonals bisect each other.
Good. The diagonals bisect each other. What do we know about consecutive angles? What do we know about those angles? Halen? They're angles that share a side, yes, but what do we know about them in regards to the parallelogram? That is true for the definition. Kale?
They're supplementary.
Good. So consecutive angles would be supplementary. I bet I had all the answers under this box. I was missing some. So, we got them all now. Alright, so today you can see the title of the notes is Proving Parallelograms. So we will be able to prove if it is a parallelogram or not. You'll see a lot of questions like these on your next test. They're yes/no questions. Is it a parallelogram, yes or no? Say why. You'll be surprised how many of you will miss them. So they're not hard questions. It's either you know the properties or you don't. So you want to make sure that you're memorizing them. You also want to make sure that you're actually completing your homework to the best of your ability every night, because that is how you prepare for a test moving towards it. So make sure that you are not rushing to complete your assignment, but actually completing it, thinking it through, because those are all questions that might show up on a test. Oh, okay, let me go back. So, question 1. Is it a parallelogram, yes or no? Explain. Looking at the picture, is this a parallelogram? Yes. See, head nods. This is the definition of a parallelogram. We have both pairs of opposite sides that are parallel. The next one. Some of it you'll have to use prior knowledge to figure out, do we have parallel lines or not? What do you think? Kale?
Yes, because the opposite angles are here.
Yes. I would not agree with your reason though. In order for opposite, you would need to say like this whole angle is congruent to this whole angle. But those are a type of angle that we know. Maddie? Good. These are alternate interior angles. And we know that the converse of the alternate interior angles theorem says if AIA are congruent, then the lines or segments are parallel. We also have these, which are alternate interior angles. Since they're marked congruent, then yes, we know those are parallel. So this would be yes. Using the converse of AIA, we could prove that we have 2 pairs of parallel sides. And you could, instead of writing converse, you can still say, since the alternate interior angles are congruent, then we know that the segments or lines are parallel. And I don't know why there's this little icon box on there. That's just an error. This is not part of the problem. That's just there. Do we think this is a parallelogram? Yes or no? And explain. Some of these questions are, if I remember correctly, almost exactly like test questions. Maddie? No. Okay, if you notice, this is acting as a transversal, alternate interior angles, which would prove the top is parallel to the bottom, right? Now the other pair of alternate interior angles go along this transversal, but they still alternate in between the top and the bottom. So that just also proves the top is parallel to the bottom. So this would be no. Right now we only have one pair of parallel sides. How about the next one? Thing. No?
No.
No. You actually don't know anything is parallel because the alternate interior angles are not congruent. So in that case, you don't know anything is actually parallel at all. So all of these problems were just using the definition of a parallelogram. Does it have two pairs of parallel sides? Now we're going to throw in all of our converse theorems from yesterday. Some of them are on the front, some of them are on the back. So theorem 6.5, again, the numbers are irrelevant. The content is what you want to know. It says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So yesterday we learned if it is a parallelogram, then the diagonals bisect. Do you see how it's just the converse of the statement? So we're going to see if we see a picture that looks like this, and we know that both diagonals are bisected, then we will know, indeed, it is a parallelogram. The reason they don't call these the converse theorems is that the theorem doesn't have a name. So usually it was like AAA theorem, we did converse of AAA theorem. Since they're using numbers, they just actually make a new number to stand for this theorem. But it is just a converse theorem. So the next set. First one, is it a parallelogram? Yes or no? Do we have enough information to prove it's parallelogram? Justin? No. We only know that one diagonal is being bisected. We don't know both. Just pay really close attention to the markings. How about the second one? Lexi, what do you think for the second one? No. The markings don't show that they're actually being bisected at all, because it should be like one marking, 2, and 2. So this is really no diagonals are bisected. The next one's kind of like the same exact question, just a little bit different. So it's a no. I'm just going to draw an arrow. I know yours is right next to it. Same reason as the last one. And then how about this last, the fourth one? Maddie?
Yes.
Yes, this is showing that both diagonals are bisected. All right, now the next theorem is the most important theorem because this is a new one from today. So let's start up. You want to memorize this one. This is one that a lot of you will forget. Therefore, you will tell me that it is not a parallelogram when it should be. So this one says, if one pair of opposite sides of a quadrilateral is both, I should probably say are both, parallel and congruent, then it is a parallelogram. So if you know that just one pair of opposite sides is both parallel and congruent, that is enough. So this is a new one. This doesn't satisfy any of the properties we learned yesterday. Now, really briefly, I'll show you why. Well, let's put, then it is a parallelogram. I'll do like a little mini proof just explaining it. So if we were to draw in a diagonal, okay, we would then have two triangles. We can prove these triangles are congruent. What's one thing I could mark on that triangle that I know is congruent between the two triangles? Joseph? The shared side. What else? Maddie? alternate interior angles. Only this pair though, because you only know the top and bottom are congruent, or parallel, excuse me. Then the triangles are congruent by which triangle congruence theorem? ASA, SSS, SAS. Maddie? Side angle side. Okay. If the triangles are congruent, remember that acronym CPCTC, corresponding parts of congruent triangles are congruent. So you would be able to then prove that, you know, this is congruent to this, corresponding parts. You would be able to prove that this is congruent to this, corresponding parts. And if those are congruent angles, then that means the converse theorem would tell you that the other sides are parallel. Okay? But you want to remember, and since we've kind of marked this all up, maybe draw it again with only the two markings. If one pair of opposite sides is parallel and congruent, the answer is yes, it's a parallelogram. Okay? A lot of you will think no, because you don't have both pairs of sides, but this is that special theorem. So looking at the ones below, we see this pair is parallel, but this pair is congruent. This would be a no. It has to be the same pair. So you would either need to know that these were the congruent ones, or you would have to know that these were also parallel. Okay? So one pair is parallel, one pair is congruent. It has to be the same pair. Now the next one gives us some angle markings. So again, some of you like to trace the corners of the angles. We should notice that those fall along a transversal and in between parallel lines. So these are alternate interior angles. If alternate interior angles are congruent, then the lines have to be parallel. So this one now falls under the theorem we just talked about, so yes. One pair of opposite sides are both parallel and congruent. And if you want to for your notes, you can jot down that we used converse of AIA. I've heard that. So you guys can answer the next two. Yes or no, and then we'll pair share. Not that anyone's watching. I'll watch. You don't have to, you're in class. Alright, on the back, two short theorems that are just yesterday's theorems in converse form, and then a couple algebra problems. Theorem 6-7 is the converse from yesterday. If both pairs of opposite angles are congruent, then it is a parallelogram. You have to prove both pairs, not just one. Okay, so if you know that these are congruent and these are congruent, then you have a parallelogram. Big mistake. Some students will say, oh, one pair is. I got 70 and 70. Well, the others have to be 110 and 110, right? Because they're supplementary. But if you don't know it's a parallelogram, you can't use same side interior angles. So just be very careful. If both pairs of opposite, oh, I did this one wrong. I didn't read. I'm sorry. Let's just change. No. It said sides in this one. I read the second one and marked the first one. I apologize.
Of course not. I'll never do. I'll have a pen.
You could just draw an arrow and like change sides to angles if you wanted to. I apologize. I mixed. So the next one says the angles. So this one was supposed to be both pairs of sides. This one was supposed to be both pairs of angles. So if both pairs of angles this time are congruent, then it is a parallelogram. Usually school hasn't even started yet, so that's my defense. Last 3 days. So example 4, the algebra problem. Basically the same problem as you did yesterday. The directions will just now say, find the values of x and y for which ABCD must be a parallelogram. So So yesterday it said ABCD is a parallelogram, find x and y. Now they're just saying find x and y to prove it's a parallelogram. Same problem. So we know in this picture that if it's going to be a parallelogram, the diagonals have to bisect each other. And this one's actually an easy one. If we don't want to solve it, we don't have to. But setting up our equations, 8x plus 12 equals 10x minus 24. Part to part. The other one would be what? You can tell me the second equation I would write using the other diagonal. No?
2y minus 80 equals y plus 10.
Good. And then you guys know how to solve those. If you don't feel like it, we don't have to continue. And then 5 and 6 also are yes, no explains. And this is one that I was kind of hinting at. You want to be careful with the theorems. That's why I circled the both part. Determine whether the quadrilateral is a parallelogram. Explain. So think about these for a second. And let's pair share. Write down your answers and we'll see what your partners think. Especially be careful with, put this on.
Oh, 360.
How many degrees are inside of a quadrilateral?
360.
360. So you can take 360, subtract, 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 and you will prove that this is 105 using quadrilateral sum. And then you can say that yes, both pairs of opposite angles are congruent. You'd have to use quad sum. Okay, the last one, let's just write the equations. We don't have to solve them, but let's make sure that we can write them because that's important. We have a same thing. We're finding the values of A and C to prove that it is a parallelogram. So we know that the opposite sides have to be what? Congruent. And we know that consecutive angles have to be supplementary. So who can give me one of the equations we would write? No?
A plus 40 plus A equals 180.
I'm going to have that one over here. A plus 40 plus A equals 180. So those are supplementary. Who can give me the other one? Using the sides. Marquise?
3c minus 3 equals c plus 1.
Good. And then these are easy because this one has C's, this one has A's. You just solve each one separately. Okay? We'll end up getting 70 and 2.